Hello and welcome to the Google Cloud Advanced Computing Community. I am Jay Boisseau and I'm very happy to have you all here joining us. And I'm happy to be back after having to miss the last couple of weeks from these sessions. I'm thankful to Adnan Khalil for taking over as the MC for me. I'm back in town and looking forward to not only MCing today, but to being the presenter today and reconnecting with all of you and seeing you all in chat and everything. So for those of you who are new, I am Jay Boisseau. I am the Google Cloud Advanced Computing Community Director. My official position at Google is as an HPC product management team, outbound product manager. In that role, I serve as an advanced computing strategist and as the Google Cloud Advanced Computing Community Director. I have about 30 years of experience in advanced computing, mostly in high performance computing, more recently in AI and a little bit of quantum computing, starting to get into that more as well. And that is the kinds of technologies this community covers. So I want to welcome you all and explain very briefly to the new folks what we are. We are a community of practice. That means we present information that is useful to practitioners of advanced computing technologies, developing them, using them, selling them and marketing them, collaborating on research around them. So very much a community of practice, but it is open to everybody, including people who may want to move into professional careers in this space, because we want to build expertise that accelerates innovation and research discovery. So how do we do this? Well, we have this community that has weekly webinars, and we invite people to join these, and it's open to anyone to join the weekly webinars. So whatever your background, we try to make these presentations such that even if you're not an expert in advanced computing technologies, you will learn fundamentals in each of these presentations. There may be some more advanced material in some of them as well, but we find that the technically savvy public is able to consume this great content and build on their skills. We also have in-person workshops, and those are meant for more hands-on skills, practitioner development and expertise enhancement. So we hope that you'll come to some of those in-person workshops as well. And finally, we have networking events at major conferences. So with all of that said, who is this for? Well, it's really for Google and our partners and our customers who are all users or developers of advanced computing technologies. That forms the core of the Google Cloud Advanced Computing community. As I said, though, it's open to everyone. So analysts and media are welcome, potential customers, potential partners, and the general public at large. And you'll find in each of these sessions, it's a mix of all 7 of these groups attending, introducing themselves in the chat space, asking questions of each other sometimes in the chat space. We do have a website and a YouTube channel, and I want you to be aware of those because the website is how you find out about upcoming topics in the webinar series and how you register for in-person events. The YouTube channel is how you catch content that you missed. And we've seen our YouTube replays really go up lately. So apparently word is getting out about our great YouTube channel and the content there. If you haven't seen some past lectures, I invite you to scan that and tune into some of those presentations. Let's see. Oops. Sorry, skipped over that slide accidentally. The community guidelines and Google Meet features. So one more thing that I do want to share, professional conduct is required at all times to participate in these sessions and in our in-person events. And that means respectful communication. So when you use the chat space and the Q&A feature, please use them respectfully. The core principles here, we're all here to learn. Not everybody has the same level of expertise on every topic. The old phrase, there are no stupid questions, applies here. Feel free to ask questions. You can ask questions of each other in the chat space, but you can also use the Q&A feature in the bottom right to ask questions that you want me to ask the speaker at the end. In today's case, I'll be asking myself those questions. So submit your questions in that Q&A feature, and I will tackle some of those towards the end. And finally, we have these meet emojis at the bottom of the screen. If you click on the smiley face in the bottom center, you can see meet emojis. Now, we don't encourage overuse of those, but when you agree with a point, you might hit the plus sign. If you want to celebrate a point, hit the, what is that, Mary? A horn with confetti coming out. If you disagree with the point, you can use that crab sign that David Liu is unfortunately using, and so is Adnan. I hope that's just for demonstration purposes and not for my explanation of how to use meet emojis. So with that, we're going to jump into today's presentation. We actually have a two-part presentation. Today is going to be a very high-level look at what agents are. So we've nicknamed it Agents 101. It's about decoding AI agents and agentic systems. If you already develop AI agents, this session may not be for you, but hopefully the way I phrase some things might still be of interest to you when you have to explain agents to other people as well. I hope that everybody will find it interesting. Next week's will be a bit more advanced, so I encourage even people that have some agentic skills to tune in next week in particular. But hopefully everybody will find today's, it's about 30-minute presentation valuable. So first though, for the folks that aren't familiar with how AI is used to create agents, just a few quick slides as an AI refresher. This is what the AI landscape kind of looks like if you made it into a Venn diagram. Now, one thing about Venn diagrams, they're always approximations of reality, but this one's pretty good. AI is a very large field, and the dominant field right now within AI is the machine learning approach to AI. 20, 30 years ago, it was the expert systems approach. Now the machine learning approach is the dominant approach used in AI. It's not the only approach. There are other ones. And in fact, in last week's session, you saw a different approach to AI, active inference AI. But in enterprise and in popular use today, machine learning is the dominant branch of AI. Now, deep learning is the dominant subset of that that you hear about in the news a lot. Classical machine learning is widely used in enterprise, and there are many problems for which classical machine learning is exactly what you want. But what really gets a lot of the headlines these days is deep learning because of its ability to find patterns in unstructured data and then provide great classifications and analyses and predictions based on training on lots of unstructured data like audio and video and text. And then generative AI is a subset of that, in which we're using deep learning based techniques, not just to make classifications and predictions, but to actually generate new content. Here is a very brief history of generative AI innovation in only 3 steps. In 2017, Google published the important paper, Attention is All You Need, where it revealed the transformer method that is a way of training a model on a vast amount of unstructured information and understanding the level of attention between different kinds of unstructured data, between different words and features in an image and features in audio tracks and such. And by training models using this transformer method, it made it possible to generate new content based on user-provided prompts or information provided from a system, as we'll find out later in the presentation. The generative AI boom, however, didn't start for 5 more years. And that's when OpenAI released ChatGPT to public free use. Now, it hallucinated a lot in those days, but the public still found this conversational interface to be able to query a chatbot about all or essentially all of the world's published information and get answers back in conversational format and to be able to iterate in that. They found that very compelling and very powerful, and you've seen many companies that had this technology in the back of the house then bring it to the front. We've seen startups like OpenAI and Anthropic. We've seen companies like Google that invented this technology, and Microsoft and Amazon and others are all releasing tools and technologies, products and solutions based on generative AI. We're very proud that earlier this year we released Gemini 3.1 Pro, which moved to the top of most of the benchmarks for generative AI models. It's native multimodal, but it does extremely well on the hardest tests that have been developed so far. It's a very competitive leadership frontier model. So you're also probably all aware of this, Gen AI chatbots and the hallucination problems. So LLMs are probabilistic prediction engines. They're not databases. You should not use an LLM when what you really mean to use is a database, and a SQL query will give you a very precise, deterministic answer back. That doesn't mean they're not incredibly powerful. Of course they are, but you always want to use the right tool for the right job. And you need to remember that LLMs while trained on vast amounts of public data and able to consume in enterprise modes your own company's private data safely and securely, are still not calculation engines in the sense of a calculator or a SQL database. They, in general, lack access to real-time private enterprise state, although we're going to talk about how that's addressed coming up. The result is very confident fabrications, especially in the early days. Now, all the major chatbot providers have done things to greatly address the number of hallucinations, both through reinforcement learning, through human feedback, through checking with external sources and whatnot. But that was a real problem in the early days. And the business impact was that raw LLM chatbots are unsafe for mission critical applications or things where you really need deterministic output. But we started to learn how to address that with retrieval augmented generation. And that is where the user still injects a prompt, but you have now created a vector database of your information that you consider trustworthy information. You consider it ground truth information. It might be private data in your enterprise that your own experiments or results have determined to be true. It might be sources of information in the world at large that you trust, and you fold those into your RAG database as well. When you insert that RAG layer between the prompt and the LLM, it infuses the prompt with ground truth data that is used in the answer, and that prevents it from going astray in most cases. So it generates text that is high probability of being accurate. Now notice that I didn't say guaranteed. There's always a chance, even in RAG methods, of having a hallucination, but it's greatly reduced when you ground it in this kind of data. But note that a RAG just informs, it does not execute. That's where agents are about to come into this conversation. So it's very powerful, it's very accurate, but you're still trapped in a conversational mode. Now, if you're familiar with Google's Notebook LM, that is a very quick and easy way of grounding in what you consider truthful data and information. So Notebook LM is very powerful. It not only allows you to upload information that you consider truthful, but it also constrains your results to only being about that truthful data. So it's a great way to use a RAG-like technique to get true results. But again, conversational. It's not fully agentic in the way that that we're going to talk about in this. And even that requires a modification because we're doing things behind the scenes. But for right now, think of Notebook LM as just a really wonderful implementation of RAG. So the evolution of these AI capabilities, we talked about deep learning and predictive AI. And note that predictive is used generally here. It does not mean just predictions of time series of future events. It can be predict as in classify. Is this an image of a cat or a dog or a bridge or something like that? So predictive AI based on deep learning techniques, then generative AI based on transformer methods in deep learning. And now we're moving into this agentic AI era. And this is not about what is this or what will happen, or simply create this content for me. Now we're in the era of achieve this goal for me. So this is very powerful. It depends on generative AI, but it depends on other things as well. Generative AI alone can make a great chatbot. Generative AI plus some other technologies can take actions and achieve goals. One quick aside here, you might have heard of robotic process automation and wonder how that differs. Are these AI agents just a newfangled form of RPA? And the answer is no. RPA techniques are by design deterministic. They're very much the explicit if-then kind of logic. They're rules-based, so they're limited to predefined paths. That means there's a weakness. They're not good on edge cases. If it's something that doesn't fall into your deeply nested if-then loops, it doesn't know what to do. So it's really good when the possible outcomes are completely constrained, but not good when you can get different kinds of scenarios that it can't account for in the explicit programming that was required to generate these deterministic methods. AI agents, on the other hand, are reasoning-based. So because they're reasoning-based, they are able to handle ambiguity much better. Now, They navigate ambiguity with LLM-based reasoning. They are goal-oriented. So you can give them a goal and they produce that goal. And you can give lots of information about the kind of goal and the way you want the output to be structured for that goal. And they're very, very good at that. And they're self-correcting because they handle that ambiguity well, and they'll make a best possible assessment of what to do next. So they can adapt in that regard. All right, so this is really a major paradigm shift if you think about it. We are moving beyond building chatbots. In this agentic AI era, we are building stateful microservices with reasoning engines. And I want this sentence to sink in because it's very, very important, and it does not diminish the importance of chatbots. I hope all of you are using them all of the time, especially for learning. They're great ways to query the world's published information and quickly increase your expertise on just about anything that's ever been published in any form, because it's been consumed into various companies' frontier models, and they are become very good at conversing with you and teaching you that information. They're very good at lots and lots of things, but they're not the things to take the actions. This is where we shift from generation to action, and this is where agents come in. So what is an AI agent? I've mentioned the term several times. I've mentioned what they do. You give them goals and they take actions to achieve that goal. They really have three fundamental parts. They have a brain, they have what we might consider hands, and they have memory. So that brain, the thinking part of that, is based on an LLM or a foundational model. For example, Gemini. This is for the complex reasoning and planning that needs to take place to achieve your goal, that may require different tools, multiple steps, sequences of actions, and analysis from the results of those actions, etc. LLMs are really good at all that, but they're not the doers. They're the thinkers and planners. So they need hands to actually do things. And this is where API integrations and function calls come in. And that enables the plans and the next steps that the brain has dreamt up here via the LLM, and really via the goal you've given the LLM, and then the LLM planning a way to do it. This is what enables them to mutate the external world state in some way, is these API integrations and function calls to specific tools. And we're going to show some examples of that. And then memory. If you really want these systems to be able to reason and execute steps towards goals, they need to have memory. And this means both short-term and long-term memory. So you want long context windows, which are the short-term memory, and you're familiar with those context windows from using chatbots. And we've been very proud at Google to have a very large context window for Gemini for a long time, 1 million tokens in that window. But you also want persistent storage when you're dealing with agents, and that's for stateful continuity, because you want to build stateful systems that persist. And we're going to see that these agents actually execute a loop, and these loops can run infinitely depending on the kind of goal you give it. It might be a monitoring and action kind of goal. They might have a well-defined task that they complete. They might have a role they play that is just a continuous monitoring task, but it executes this cycle that you see on this slide here. So the Gen AI model, the LLM, it determines the next logical step. Think of that as the thought part. And then it creates an action. And it does this for the tech developers on the call. It does this by a structured JSON to trigger a tool via a protocol we're going to talk about called MCP, or to influence another agent by a protocol we're going to talk about called A2A. So the LLM thinks and reasons and plans. It takes an action through a API call or function call to trigger something that is either not an agent, it's a piece of software or a control system or something, or is another agent. Then it observes and interprets the response, and it uses that to plan the next move. So your agent here is using this REACT framework for reason plus act, and it's doing it in a loop. So it's constantly reasoning, acting, observing, and then repeating, reasoning what to do next, what action to take next, and observing. And because it runs in this loop continuously, this can be a very powerful capability to run different kinds of controls and control different kinds of systems. So there's some tool calling mechanics here, and we're going to talk more about the technologies in next week's lecture. But I did want to show you a bit of code here and show you how doc strings become system instructions. So developers are familiar with doc strings that give humans guidance on how to do things. But in agentic systems, doc strings become system instructions for the model to understand tool capabilities. And yes, we've kind of anthropomorphized the whole system because LLMs are based on human language, trained on human language. And so we've made these things that compute zeros and ones, understand and talk to us in human language, and even talk to each other and send information back to each other in human readable language. But what this leads to is deterministic execution of external functions based on generated parameters. So once you get a decision made, it then takes deterministic steps in what it connects to via MCP, or at least a deterministic bit of information it passes to another agent. So it is true that the LLM is probabilistic, but the steps it takes once a decision is made are deterministic, and it can execute deterministic actions via these calls to functions and APIs that execute other kinds of software. Now, a really critical thing here is state management. You saw on the previous slide, I'm going to go back to it for a second, 2 slides ago. This is a loop. And in most cases, your agents are existing and running, and you can think of them sort of as cron jobs, but smart cron jobs that are always reasoning and planning and acting and then observing and then making new decisions on what to do next. But state management is really everything here. The agents must know where they are in a workflow and must manage infinite loops or maximum iteration counts and whatnot. And so this is important because you have to continuously ground the agent in the state that it's in and the state of conditions. So the context window is like it's short-term memory, and it remembers a tremendous amount about things, but context windows, even large ones like with Gemini models, are still finite, and you're running this loop continuously for very long periods of time, perhaps with no plans to stop the loop unless it fails or you need to force an interrupt. And thus, you will need some ability for long-term storage as well, and the ability to save reports that can be fed back into the analyses. So this is where you get to short-term versus long-term memory. The short-term memory is the session context window. It's always important to have context windows that have large token limits so that you can store lots of context in short-term memory. But you can use vector and graph databases for long-term memory. And that gets written to persistent storage, which means your agentic system always has access to past information, analyses, reports, etc. And this enables cross-session user preferences, historical facts, etc. And this is why you can have a continuous long-running agentic system. You're not limited solely by the context window that you are in chatbots. Okay, so these agents can do some things, and I'm going to show you or talk about a few examples today and show you more next week. But that doesn't mean that they are perfect for everything. So when should you not use agents before we get into a bit more about how to design them, how to use them in examples? Well, you don't use them if you have high latency requirements. And for any of you who've used chatbots, which I assume is everybody on this call, you can witness the latency of chatbots generating content for you. All right, now they're just generating content and it's displaying on your screen as new tokens get generated. And of course, there's lots of talk in the industry about how to make inferencing go faster, when to use smaller models like Gemini Flash versus larger models like Gemini Pro for certain things for which the accuracy won't suffer, but the speed will go up. But you've all witnessed the latency in generating content. That latency exists in LLMs because they are doing, they're taking actions based on these incredibly powerful, complex trained models. It may not seem like a long time, the latencies as you watch your tokens come back in a chatbot, but if you think about it, there's many mission critical applications for which that kind of latency wouldn't be tolerable. You also wouldn't use them if you really need strictly deterministic linear workflows. We have decades of experience programming explicit techniques, deterministic software applications, etc. They continue to have their place, especially in mission critical applications where you need to be able to predict and or understand after the fact exactly what happened and why. So there's still a tremendous need for deterministic linear programming for such workflows. And you would want to be careful when you're cost sensitive to microtransactions. You can generate, well, with each token generated, whether it's in your chatbot window or behind the scenes by your agents that are generating doc strings to create actions and such, the cost can go up. The agent loops may be running persistently and continuously. And so this can generate a significant cost in microtransactions over time. So you want to be cognizant of that, and when another technique might not be continuously generating microtransactions. So let's talk about architecting agents and a little bit of reference to Google Cloud. This is mostly going to be general, and next week will be more specific about Google tools, but I wanted to share a little bit with you here about how to do it on Google Cloud. First of all, Vertex AI Agent Builder. We have this wonderful platform, Vertex AI. It has a model garden where you can access not only our models, but other companies' models and open source models. It has an agent builder in that. I invite you to learn more about this between now and next week. We'll talk about it a little bit more next week, but it's an enterprise-grade platform that helps you build agents. And it's a managed platform, not just an API. It helps you build enterprise-grade agents that have all the enterprise level of privacy and security and reliability that you'd expect for Google to host these on its own platform. And it's really versatile in deployment. You can vibe code agents in here, and you can use coding first, code first, code intensive techniques to create agents using Agent Development Kit. So whether you're a novice agent builder or an experienced programmer who really wants to dive in and build the agent yourself, you can do both of those extremes using Vertex AI Agent Builder. There's also a Vertex reasoning engine runtime environment. As I mentioned, these agentic systems run a loop and can run persistently until a goal is achieved, and that goal may be to do something persistently itself. And so the Vertex reasoning engine runtime in our environment, it acts as your React orchestrator. You're going to see orchestrator be used again here in a second, and state manager. So it orchestrates one or more agents, and it maintains state information about the state of the agents and the overall workflow. It is a serverless architecture, so it's explicitly designed for agentic graphs. Provides native support for open source frameworks like LangChain and LangGraph, and it gives you infrastructure abstraction. And this is really important because if you're developing an agentic system, you don't want to worry too much about the details of the underlying infrastructure in most cases. You'd rather define your agent logic in something like Python, deploy it, and let Google manage the underlying compute, scaling, and endpoint provisioning, all of which may change dynamically depending on what your agentic system is doing, what the goals are you've given it, what tasks it's trying to execute, what the conditions are at any given time while executing those tasks, for which it is analyzing, it's observing and analyzing the results and making its next plans. So abstracting the infrastructure can be very useful in agentic loops. Now, I mentioned MCP before, and hopefully many of you have heard of it. In fact, I am curious. I see there's roughly 70 people in this call. Why don't you hit the thumbs up emoji if you've at least heard of MCP before? I'd like to see if a lot of folks have. Great. All right. Well, this is the standardized integration way of integrating agents with non-agents, with things that perform specific tasks like BigQuery, Google's SQL architecture and solution, or with Jira or with Workday. You generally want agents, well, almost always want agents to do something for you. But often what you want them to do on the back end is deterministic and better handled by a non-LLM tool. So again, the agent becomes the brain. MCP gives it the ability to communicate with its hands, as we described before, to use tools like BigQuery, Jira, Workday, and many, many other things. So Anthropic came out with a proposed standard for this, and virtually everybody is adopting this model context protocol. And this is kind of like the USB-C of having agents be able to talk to non-agents. So when everybody adopts MCP, they're basically willing to say, oh, my tool, my Slack instance, my Jira instance, et cetera, is willing to let your agent talk to it through MCP. And this decouples agent logic from the back-end infrastructure. So MCP is just as necessary in these agentic systems as something like USB-C is to connecting a wide variety of different devices that are coming out all the time, and different people are developing different hardware, but USB-C gives that hardware connectivity standard. MCP gives this agent to tool connectivity standard. Google also provides a cloud API registry so that you can register agents in there and what they do. And this is important because once you have these MCP servers, you publish them to the cloud API registry, and this gives you enterprise features, centralized governance, et cetera. It also allows your administrators to manage the API versions, monitor their usage, control exactly which tools, which agents, all in one place. So it gives your admins control, it gives you this reliability and security, and it provides this centralized governance and versioning. Even allows you to begin deprecation of agents as you replace them with newer capabilities. Of course, there is a code execution sandbox. A reminder is that LLMs are bad at math. They're good at writing code, but bad at math. We mentioned that because they're probabilistic, not deterministic. Earlier in the presentation, I mentioned that LLMs are incredibly powerful, but you don't want them to replace a calculator or a SQL database or something. What Vertex allows the agent to do is generate Python code, drop it into an isolated secure container, run the compute that is good at math, run a calculator application, and return the deterministic output to the reasoning loop. And this is why your chatbots also seem better at math, because behind the scenes, your things like this are going on that when a calculation is recognized, don't have the LLM try to predict probabilistically the outcome, actually behind the scenes make a call out to something that is meant to be a deterministic calculator. So how does this reposition RAG in this agentic world? So RAG just becomes a tool now, like a calculator or interpreter or SQL agent. RAG becomes a tool to provide trusted information that can be used by the agentic system. It might also use search to call out to the world to find what it believes is trustworthy information, including information that may be newer than the last time the model was updated. We know these big models get updated every few months, but there's constantly new information published that they should have access to. So call outs to search, and then call outs to retrieval augmented generation vector databases become a very important tool that can be used in an agentic world, as do calculators, interpreters, SQL agents, etc. Okay, so if one agent is good, should you make one huge agent to do everything in your life, or should you make multi-agent systems? I've probably given away the answer with the title of this section, but let's talk about the God agent anti-pattern, right? I strongly suggest you do not build one massive agent to handle 50 tools. Just like we've all learned in programming classes our whole life, it's better to build dedicated, purpose-designed tools that you can connect and reuse rather than these monolithic applications and tools. So if you try to do this with agents, it can lead to context dilution and tool hallucination. So remember, you've got a short-term memory window, which is your context window. You don't want to have it filled up with the outputs from 50 different tools. You want each tool to have its own context window associated with its own agent and its own agent brain, its own LLM. And that means that there's more short-term memory available to the specific task, and thus you get to use that entire context window of short-term memory for that. So what you really want to do is have a micro-agent architecture. A very common way to think about this is to have an orchestrator agent, and it might just call other agents individually. It might call a SQL agent when it needs to, a Python agent to write some code when it needs to, an email agent to check your inbox and send messages out on your behalf or something. Always a dangerous thing, and we'll talk about that coming up too. So you really want to use the single responsibility principle for your AI agents. Define agents that have a single responsibility. The narrower the scope, the higher the accuracy. Now, you still may have many agents now. You may have 50 agents instead of one agent running 50 different tools. And you should think about the structure of that. You can call it a topology. So you might have a very linear kind of workflow that you might still be looping over, but within that loop, it's a linear flow. And so you can structure your agents in a sequential pipeline there. It might be more hierarchical. You've got an orchestrator agent that is delegating work to specialized co-worker agents as needed. An emergent peer-to-peer collaboration model for agents is the swarm, this all-to-all model as well. And there are certain workflows for where an all-to-all model actually makes more sense and will give you better performance than a hierarchical or sequential pipeline. So think about your workflow and the order of instructions that are likely to be given by the brain, the LLM, to different agents. And then you'll want to structure your agents to talk to each other using A to A, which we're just about to get to, in the right topology instead of having to go through other agents to get to the agent they really needed to talk directly to. And so they talk to each other with this A to A protocol. And this, like MCP, is a universal standard, but this is for agent-to-agent communication instead of agent-to-tool communication. So it's cross-platform and cross-vendor interoperability, and that is a wonderful thing in this era. The agentic era of AI is relatively new, and it's moving so fast that it really needed standards to be adopted so that you could plug in different models, not just different models from the same vendor, but even different models from different vendors and makers. And MCP and A to A, thankfully, it didn't take as long as it took us for USB-C on hardware to get to having these two standards that make it possible to develop these powerful agentic systems. And it leverages standard web technologies like HTTP. It leverages JSON RPC for what you might consider the envelope of the instructions, but A to A messages can be different format. MCP, it's JSON all the way through. For A to A, you think of the envelope as being JSON, but you can use different formats for the actual message inside of that you pass to other agents. So human in the loop pauses. So up to now, I have probably made it sound like, oh, these are fully autonomous systems. You just turn them on and let them go. You can do that. But remember what we talked about at the very beginning. The brain itself of these systems, the LLM, is probabilistic. And despite the tremendous advances in training LLMs and being able to ground them in data that you give them, et cetera, to allow them to run forever or to allow them to run through highly ambiguous scenarios presents some risks, especially for mission critical operations. And so for some situations, you really want to serialize the agent state to a database and use pub/sub triggers for human review. So you might have a complicated AI system that is doing many things on its own, but there might be phases in which you want to introduce this human in the loop pause for the expert in the room, the human, to weigh in and decide, should it keep progressing? Should it keep running this react loop continuously? And so this is called rehydrating the state to execute these high stakes actions. Humans and expertise remain important. And this gives a technique for ensuring that in mission critical things where human oversight is important, that it's easy to code into these agentic systems. So don't fear that you're only building autonomous React loops. You can build React loops that also present an opportunity for the expert to weigh in. Let's see, it's 41 minutes past the hour. I'm going to talk about this fairly quickly. Many of you probably know what IAM identities are. The main point of this slide, IAM identity management, and using that, well, really the main point is the next slide. It can help you mitigate prompt injection, because if you use strict IAM, which is, actually, I will go back to this because I want to make these 3 points here. IAM helps determine who are you, what are you allowed to do, and which specific things can you touch. So your IAM identity in a computational system answers those 3 questions. The agents are first-class IAM principals, and they have strict least privilege access to prevent data spillage. So least privilege means you can only do certain things. There's no assumption that you should be able to see or do things outside of a finite scope based on who you are. That helps determine what you're allowed to do and which things you can touch, and thus what things you're not allowed to do and what you cannot touch. And by following strict IAM policies, you can mitigate these confused deputy attack where a malicious prompt may trick the agent into dropping a table or something. This is really important and protection for these agents, because again, they are acting in the background. Again, we're all familiar with daemon processes and cron jobs and things like that that are acting in the background in computational systems. But the LLMs in these agents are handling and making decisions based on ambiguity. And that means there's always a possible chance they'll make a wrong plan, call a wrong tool, do something. But through strict IAM adherence, they will still not be allowed to do anything not prescribed based on the IAM identity. This becomes important in CI/CD and agent evaluation pipelines. It's important to note you can't really unit test a non-deterministic piece of software. The concept of unit tests is very important in testing software, and we're all used to thinking about, oh, you write the piece of software, you test it against a unit test. If it passes, you know it's good. And you may have a whole set of unit tests that it have to pass, but then you feel fairly confident that it's bug-free. You can't unit test non-deterministic things, and the brain agent, the brain part of the agent, the LLM, is non-deterministic. So in CI/CD pipelines, you kind of use LLM as a judge framework. So you run the agent against hundreds of historical tasks, maybe thousands, and measure the tool selection accuracy. How often does it make a plan that calls the right tool versus the wrong tool? How often does it complete the tasks that it's beginning? So there's a lot more testing that goes in. You can't just do simple unit testing anymore in the CI/CD normal kind of way that you would do with explicit coding, with RPA, etc. So it does change CI/CD quite a bit. Some real-world examples and wrap-up. There are some real-world agentic tools in the wild. I'm willing to bet everybody on this call has heard of Claude Code. Probably most of you have heard of OpenAI Codex. I hope most of you have been tuning into our presentations and seen our Gemini CLI and seen Anti-Gravity, our agentic IDE as well. These are real powerful tools for developing code using agentic systems. And these CLI native agents can do things like navigate repositories, write patches, compile code, debug errors, and then recompile the code, execute Git commands. They're really powerful coding assistants. You may have heard of Claude Cowork and things like it recently. In Google, we have similar tools in-house that ingest all of your enterprise data, documents, etc., securely, and can do things on your behalf behind the scenes. The one that's gotten a lot of publicity lately is Claude Cowork, because whereas Claude Code is for developers, Claude Cowork is for non-developers, but to help them do new things like create a new product requirements document based on all of the meeting notes and technical documents, what a template for a PRD looks like, etc. These are really powerful personal use capabilities, even if the model for where the agentic system lives is part local and part in the cloud. And then there are things like OpenClaw, which, how many people have heard of OpenClaw recently? Hit the thumbs up if you've heard of OpenClaw. Okay, good. A large number of people. I expect to see the thumb explosion. There we go. OpenClaw has gotten a lot of buzz lately. It's an open source desktop agent. The developer of it was hired by OpenAI recently, but they've left OpenClaw open source. And in fact, NVIDIA has announced NemoClaw, their version of OpenClaw, in the last few days. This bypasses these APIs entirely by using computer vision to operate native OS user interfaces in certain cases. It will act on your local system. It's not terribly secure. Almost every expert recommends deploying it on a standalone system and only give that system the passwords and access to tools that you're willing to let it use. Of course, that doesn't stop some people from, hey, I want to live on the edge. I want to let it manage my emails and manage my finances and do all of this. Don't recommend that myself. But it's certainly an interesting thing to explore, as long as you're being careful about what goals you're asking OpenClaw to accomplish for you and what you're giving it access to. Because again, once you give it access to something, it might make a wrong decision on the way to achieving your goal. A trivial example would be, you wouldn't want to tell it to reduce your inbox to 0 without carefully saying, but don't delete any messages that you haven't responded to, and alerting me if there's one that you think I need to respond to. Because a real simple way to get to 0 is just delete everything. There's some GCP use cases, but I'm not going to talk about those in this session since we're starting to run out of time and I want you to play with an agentic system. So I'm going to move directly to Google Gemini and show you how even our chatbot disguises an agentic system on the back end. So I'd like to ask everybody to open up a browser, preferably Chrome, but pick your browser. Open Gemini, and you will need to be logged in. And then you're going to click on this tools menu down here in the chat window. And that will create a drop down. And you see this right here on the screen where it says Deep Research. I want you to, in one window, have just the chatbot. And then in another window or another tab, select Deep Research. Okay. So you're going to have two windows or two tabs. One of them, you're going to use just this chatbot window right here. And one of them, you're going to launch Deep Research. And then you're going to enter this prompt in the regular Gemini chatbot window, which is going to give you a standard LLM response, and you'll watch it generating tokens. It will start quickly. You'll see the latency. You'll feel it generating the content. And then I want you in the other window to go into deep research mode and type the exact same thing. So Mary, have you already put this? You have. Okay, great. So when you do that prompt, and I'm going to do this myself. Hold on one second. Yeah, pull this prompt in. And I don't want to take the slide off the screen because I know some of you will need that, but I do want you to all enter that. I'm doing it myself. Now, if you entered it in the regular chat window, you saw a traditional response. It started generating ideas for you. Raise your hand if you've entered it in, thumbs up if you've entered it in a standard Gemini window and you started getting some information back right away. Great. Straightforward, hopefully very good answers. Hope you all appreciate how every frontier model can give you pretty good answers, even for a prompt like that. Okay, how many of you have opened it up in a second tab or window and then opened deep research mode and launched it? Okay, good. A number of you have done that as well. So what you're witnessing in that window is an agentic system in the background. Instead of just one LLM beginning to give you answers, it launches an agentic system, many agents scouring the information that's been trained into the model. And then you'll also notice in there some searches, going out to other information on the web and pulling that in. There are agents that are analyzing that information. There are agents that are comparing information from different sources. There are agents that are judging what information seems good versus what doesn't. And in a matter of minutes, you're going to get a report that is going to have more detail, references, and so on, based on the agentic deep research mode in Gemini compared to the fast chatbot mode of Gemini. So give me a plus sign if you are witnessing the agentic system reasoning, using MCP to call out tool searches, et cetera. Good. So you're all seeing that. So that's where I really wanted to get to today. That is a simple agentic system, but incredibly powerful. Is it more computationally expensive? Yes. If it's within your token limit for the month, do you care? No. Go ahead and use it when you really need detailed reports that have been judged for quality of the information, that are going to be more complete. They're going to use updated information. You don't need to use deep research mode for many of your daily queries, but there are absolutely times where you will want to use that versus the quick response. So in summary, and some best practices here as well, agents are for action, not just chat. So they execute actions on your behalf to achieve a goal. We just gave an agentic system a goal of producing some research ideas. Now that was a goal that did align with what a chatbot can do, but it was a goal that executed by an agentic system was able to call agents to do a much more thorough job of that. You want to use MCP to decouple tools and A to A to connect agents. You want to build specialized micro agents over monolithic ones, and choose a topology that matches the workflow. In systems like OpenClaw, for example, you basically have one orchestrator agent that's acting on your behalf of everything, and then it is doing what it needs with other agents and MCP tools to accomplish goals on your behalf. So that orchestrator model is very common. The swarm model is emerging for certain things, but choose the topology for your small agents, your micro agents that matches your workflow. That will give you the fastest answers, the most cost-effective answers because it won't waste a lot of extra time, and the most reliable ones because it's not going through unnecessary agents. It's direct communications just to the agents it needs. And I encourage you to try out agentic tools, take Google classes on Coursera about AI development. Agentic AI is here to stay. It is how we are going to automate many of the things in our daily lives, in our professional lives, and back-end control systems. Again, these for mission critical, you may not want to use it, or you may use it with human in the loop pauses to verify things at key steps in the process. But agentic AI is absolutely powerful and can remove a lot of human observation and effort time. They're particularly powerful in helping you code. They can be powerful in helping you create business plans and create complicated documents and things like that. So I really want you to not just embrace LLMs and chatbots, but embrace agentic AI. And with that, I will go to the question period. We are, unfortunately, I used up most of the session, but I probably have time to answer a couple of questions really quickly. Darwin Buckley says, it was healthy to contrast RPA with agentic, but my question is this: is there any drive to expose the reasoning trees in agentic? After all, an enterprise would own them as an asset. Darwin, I got to think about how to answer that and think about what I know and what is public and what is not. I think I can say very generally, that's a common request. You can force it to expose it by forcing it to take smaller and smaller steps that you control what happens and reveal the output after each step. You can ask it to share its thinking along the way. So there are things that you can do to encourage it exposing its reasoning trees. There's always a balance, though, Diarmid. I heard of someone the other day using one of these saying, I don't want to see all this reasoning. That's just slowing it down. I just want it to accomplish the task. So different people care or not care about seeing all of those steps along the way, but it's under your control to get more transparency of it. In terms of creating audit trails, agentic systems can be made to do that for each of the actions that are taken and the results of those actions. Let's see. Bill Turner asks, with IAM, do you see hardening authentic? It says auth, so probably authentication or authorization by off-device QRNG or TRNG in a fob or card as digital twinning. Bill, I'm going to be honest, I'm not quite sure what your question is there, but send me that question by email, and you know my email address, and expand on it a little bit, and I will get you an answer to that. And with that, we are at 11:56, and I have a few more announcements to make. Join us again next week for Concept to Code. We'll talk about building AI agents with Google's technologies. We'll just do it in a way that should be general enough to apply to other agent building systems as well. On March 31st, we have one of the icons of computer science, David Patterson, one of the authors of one of the seminal books in computer architecture. He has also got an adjunct appointment at Google, and he's going to give a presentation for us called How to Give AI a Bad Carbon Footprint. So in a way, his talk is how to do AI badly. And of course, he's going to talk about how to do AI well in the context of that, how to make wise decisions that might not even seem intuitive, but they're good decisions for doing it with sensitivity to carbon output, cost, time, etc. On April 7th, Bridging Scales, Accelerating the Path to Practical Quantum Classical Computing with NVIDIA. And a friend and colleague of mine, Sam Stanwyck from NVIDIA, will be here for that. We will also have an advanced computing day targeting financial services in London. So if you want to make it to our next workshop and you're in financial services, that's April 30th. If you're in the manufacturing vertical, you might be interested in the one after that on May 12th in Detroit, and we'll share more of those upcoming events. With that, please check out our website. You can use the website to sign up for the email list. We send 1 or 2 emails a week. That is all. We do not give your email address to anyone else, so you will not get any product advertisements or marketing or any of that. It's just informational to make sure you can keep up to date with what we're covering in the Google Cloud Advanced Computing community. You can also catch up on past sessions on the YouTube channel. We're even exploring how to make podcast versions of those YouTube videos that are informative enough, especially when there's graphics in the video version. So we're exploring that. I know some of you are already doing that, and thank you for sharing that with me. There's also lots of ways to try out Google Cloud for free. I want to encourage you to do that. And I want to thank our awesome team. So please hit the applause emoji in the bottom for the fantastic team that helps make these events possible. Sometimes they're speakers, sometimes they're helping recruit speakers and prep speakers. They're all involved in planning our workshops and events as well. It's a fantastic team, and I'm really honored to be able to work with them, and glad I'm done with travel so I can be back working with them more directly on these events, as well as back with you. I want to thank you all for this. We will see you on March 24th. Have a great rest of your week, and we will see you in 1 week.